Recently, Netflix released the first season of a science fiction series based on the Three-Body Problem trilogy by Chinese writer Liu Cixin. I've read the trilogy myself and watched the recently released 30-episode Chinese TV series based on it, and now the American version has finally come out. Critiquing movies isn't exactly my forte, so I won't discuss the series itself, but I'll say a few words about the physics mentioned in it. It should be noted that Netflix has gone to great lengths in this regard. They managed to almost completely omit from the three-body problem nearly all of the important and interesting physics concepts mentioned in the original trilogy. Along with these, they also discarded what I loved about the first part of the book: the philosophy and social psychology, the original discussions on the nature of the scientific method, and so forth. One can understand the creators of the American series. The original Three-Body Problem appealed primarily to those who had some background or interest in science and how scientists think. Whereas to the mass audience raised on Hollywood traditions, many aspects of the Three-Body Problem could easily seem tedious and incomprehensible. And perhaps this concept is partly justified. The series turned out lively, easy to watch, with enjoyable acting, decent dialogue, and so on, whereas the Chinese version, spanning 30 episodes, felt somewhat dull. Nonetheless, the spirit of the book and the issues it raises come through in the Chinese series, whereas the American version falls short. So, for those looking to watch intellectual science fiction, I would recommend the Chinese version, whereas Netflix's adaptation serves better as typical entertainment for a couple of evenings. Talking about the physics of the three-body problem, unfortunately, is impossible without a certain amount of spoilers. If you were planning to watch the series but haven't done so yet, you might be better off watching this video after. So, the plot of the three-body problem revolves around the conflict between Earthlings and an alien civilization that emerged and developed on a planet within a triple star system, meaning a system with not just one but three stars, closely situated to each other. The Sun, being the only star in our solar system, is the dominant gravitational center around which all planets, asteroids, and other celestial bodies orbit. For each of these, the laws of motion are solutions to the so-called two-body gravitational problem. In cases where the second body has significantly less mass than the first, in most instances, this body will orbit around the more massive one in a stable elliptical orbit. This is precisely what happens in our solar system, where we are accustomed to the regular alternation of day and night, seasons, and so on. When the masses of the gravitating objects are comparable, as is the case in binary star systems, the motion will be more complex. Both stars will revolve around a common center of mass. If such a star system is close enough, meaning the stars are located near each other, the conditions on the planets of such star systems will significantly differ from what we are accustomed to. Nonetheless, because the movement of stars in binary systems is regular, a certain periodic regularity will also exist, and the inhabitants of the planets will be able to calculate it and adapt to it. In a system with three stars, everything is much more complicated. The movement of stars in such a system will be highly whimsical and chaotic. The movement of planets in such a star system will be even more chaotic. At one time, a planet may orbit around one star, and then its orbit might appear nearly normal from our perspective. But shortly thereafter, proximity to other stars may disrupt the planet's orbit and transform its motion into chaotic swinging among the three stars. At one point, a planet could be very close to one or even several stars, melting from their heat, but shortly after, it could be at a vast distance from them, completely frozen. What's even worse, periods of relatively mild climate, heat, and cold will alternate almost unpredictably. It is in such conditions, according to Liu Cixin's idea, that the alien civilization in the three-body problem was forced to evolve and develop. To endure long periods of unfavorable climate, the Trisolarans, as they were called in the original book and the Chinese series, developed the ability of dehydration. In adverse conditions, their bodies expelled all fluids, allowing these creatures to weather what they called the era of chaos until more favorable times arrived. In these circumstances, it was crucial for the alien civilization to learn to predict the alternations of periods of heat, cold, and mild climate. And a significant part of the book and the Chinese series is dedicated to how they attempted to solve this problem. After numerous attempts, including the creation of a living computer made of humans, the Trisolarans concluded that the three-body problem cannot be solved, and thus creating a calendar was impossible. Consequently, establishing a stable civilization on their native planet was also impossible, leading them to seek another home. Their choice in this regard, for reasons elaborated in the series, fell upon Earth. In the Netflix version, the issues related to the three-body problem are presented in a highly condensed manner, resulting in the key idea of the first book and the entire intellectual intrigue around it being somewhat diluted. However, in doing so, the creators of the American series managed to retain in their film the key errors in the presentation of the physics of the three-body problem, originally made by Liu Cixin in the original work. The three-body gravitational problem indeed has no exact general solution. That is, it is not possible to formulate some function, or at least a system of functions, that would allow, knowing the positions and velocities of the stars at one moment in time, to predict their positions at any other moment in time. However, the three-body gravitational problem for a specific star system is relatively easily solved numerically. That is, knowing the positions, masses, and velocities of stars at a certain moment in time, we can calculate with a certain precision how they will be in the next moment, then similarly calculate how they will be a moment later, and so on. These calculations are generally not overly complex. Practically any computer can perform a numerical solution of the three-body problem with sufficient accuracy, and there are plenty of online simulators of three-body motion that do not require monstrous computational power. Yes, achieving a high degree of accuracy by calculating the motion of three bodies over a long period of time is a much more complex task, but earthly computers can generally cope with it. However, it should be remembered that three-body systems are very sensitive to small disturbances, and errors in calculations, which are inevitable in numerical solutions, can result in long-term predictions being far from reality. Nevertheless, if the model is periodically adjusted based on astronomical observations, it is quite possible to construct a calendar for decades or even centuries ahead, which largely mitigates the sharpness of the author's posed problem. Another issue is that such calculations, of course, will not help avoid the most catastrophic situations of planets approaching one or more of the suns excessively or moving too far away from them. However, even if they were able to solve the problem in a general sense, the Trisolarans would not have been able to avoid such scenarios. In other words, the main and most beautiful idea of the entire trilogy, the crisis of civilization unable to solve the physical problem, is actually just a creative move by the author, which, however, does not diminish the beauty of this move. The entire story around the three-body problem has another complexity. In reality, what Liu Cixin described could not exist at all. The behavior of three-body systems is not only poorly predictable, but also extremely unstable. Such systems simply cannot exist for long periods. After some time, the bodies will either collide with each other, or conversely, one of the bodies will be ejected from the system due to the gravitational slingshot effect. Therefore, a triple-star system could hardly exist as a system of exactly three bodies for a sufficient amount of time to form a planet, or especially to support life, particularly intelligent life. The exception is so-called hierarchical triple systems, such as the Alpha Centauri system. It consists of three components, two of which are relatively close to each other and revolve around a common center of mass with an orbital period of about 80 years. The maximum distance between Alpha Centauri A and Alpha Centauri B is 35 astronomical units, a bit more than the distance from the Sun to Neptune, and the minimum is 11 astronomical units, slightly more than from the Sun to Saturn. The third component of the system, Proxima Centauri, is more distant from the first two. The minimum distance between them is about 4,000 astronomical units, while the maximum can reach 13,000. Proxima Centauri's orbital period around the system's center of mass exceeds 5,000 years. Therefore, in fact, the first two components of the system can be considered as an almost independent binary system, which, in turn, forms a binary system with Proxima Centauri. hence why such systems are called hierarchical. And such systems can indeed exist for billions of years, but dramatic effects like those described by Liu Cixin are unlikely to occur in them. However, without such a setup, there would be no book, and this flaw can also be considered quite forgivable. Moreover, Liu Cixin's trilogy is replete with more questionable moments from a physics perspective, which he nevertheless allows for the sake of storytelling interests. Take, for example, the story of the so-called Sophons. The idea here is this. A journey of 4 light-years to Earth should have taken the Trisolarans 400 years, and setting off on this flight, they seriously feared that during this time, humans could catch up to or even surpass them in development, thus easily repelling any invasion. To avoid this, the Trisolarans decided to slow down the development of Earth's science. And to do this, they sent 2 Sophons to Earth, artificial intelligence-equipped remotely controlled robots, each made from a single proton. These Sophons were accelerated by the Trisolarans to near light speed and sent to Earth, to prepare it for the arrival of the new owners. I must say right away, at this point, physics, at least in its modern understanding, exits the chat. Accelerating 2 protons to near light speed is indeed possible. We can essentially accelerate such objects to speeds just shy of the speed of light today. However, other questions arise. Firstly, space is by no means empty. Even the deepest galactic voids are filled with the so-called interstellar medium, albeit very sparse. It's still gas composed of quite ordinary atoms, molecules, and the like. Yes, the concentration of these particles is exceedingly small, literally a few particles per cubic centimeter of space. However, the probability that during a 4 light-year journey, a traveling proton will collide with one of these particles is not as negligible as one might think. Additionally, protons, being charged particles, will inevitably be affected by cosmic radiation, including starlight and the like. And accounting for the influence of all these factors on the particle's flight is practically impossible. Anyway, this is a much more complex problem than achieving a sufficiently accurate numerical solution to the 3-body problem, which, as we know, the Trisolarans failed to do. But that's not even the worst part. Worse yet, according to modern understanding, no special protons can exist. All protons in the universe, as well as all electrons, are identical and indistinguishable to the point of complete indistinguishability. The principle of particle indistinguishability plays an important role in quantum mechanics, and since models based on this principle correspond well to experimental data, this principle appears to actually work. So in this part of Liu Cixin's construction, they are far from scientific. Furthermore, in the 3-body problem, the Trisolarans managed to essentially turn each proton into a quantum robot endowed with artificial intelligence. Liu Cixin explains the possibility of this as follows. Supposedly, protons, as well as other particles, are sufficiently complex objects, appearing almost dimensionless to us humans only because we observe them in ordinary 3-dimensional space. The internal structure of a proton exists in a higher dimensional space. This is a scientifically existing concept. In particular, such an approach forms the basis of string theory. We won't delve into it now, especially since it's not universally accepted, and even in the 3-body problem, its name is not mentioned. Let's consider only its aspect related to higher dimensions. To understand what Liu Cixin is talking about, imagine a ball made of crumpled paper. If we try hard enough, crumpling it, the size of the ball can be very small. But inside this crumple, there remains the same sheet of paper of quite solid size. By unfolding a 3-dimensional object, a clump, into 2 dimensions, we can make something very small, quite large. When transforming a 3-dimensional object into 1-dimensional, the difference will be even more significant. For example, the total length of a human DNA molecule is about 2 meters, but in a twisted form, this molecule easily fits into cells, the sizes of which can be hundreds of thousands of times smaller. And in these cases, we are dealing with a transition of 1 to 2 dimensions in one direction. In this sense, it is not difficult to understand how a tiny proton could, in principle, be transformed into something with cosmic dimensions by unfolding its 8 or even 11-dimensional structure into 2 or 3 dimensions. In this part of the 3-body problem, it is merely fantastic, but not unscientific. Liu Cixin describes how, by unfolding protons to sizes exceeding planetary dimensions, the Trisolarans somehow carve something akin to printed circuits on their surfaces, thereby turning protons into supercomputers, and then fold the protons back to their original sizes. However, according to Liu Cixin, how would such supercomputers actually function? In modern computers, computations are carried out by analyzing how electrons flow through various logical circuits. What would flow through the proton computer circuits, especially after folding them back to microscopic sizes? One can only guess, but that's not all. For any computer, especially a powerful yet tiny robot with artificial intelligence, energy is required. Where would a proton-based supercomputer draw its energy from? Who's footing the bill, so to speak? One of the key functions of the Sophons in the three-body problem is to provide instantaneous communication between Trisolaris and Earth, unrestricted by the speed of light. According to Liu Cixin, this becomes possible thanks to the phenomenon of quantum teleportation of information between entangled particles. That is, the Trisolarans would transform two entangled protons into Sophons, send one to Earth, then repeat the procedure for the other pair, and voila. In our videos, we've touched several times on the topic of entangled particles and quantum teleportation, and I've explained many times that according to modern understanding, real information transfer through quantum entanglement is impossible. Here, it's doubly impossible. Quantum entanglement is a rather fragile and unstable state, breaking down practically with any interaction with one of the particles. Even if the protons initially transformed into Sophons by the Trisolarans were indeed entangled particles, they would hardly remain so through all subsequent transformations. In general, as I've mentioned before, this part of the three-body problem can no longer be considered entirely scientific. And worst of all, by introducing his Sophon theory, Liu Cixin reinforces the already widespread incorrect understanding of the term quantum teleportation, which is certainly not ideal on his part. Why were the Sophons sent to Earth? In Liu Cixin's trilogy, their main task was to disrupt Earth's science. Unfortunately, this moment is portrayed in the Netflix series absolutely disgracefully, or rather, this concept, one of the most important in the entire novel, receives shamefully little screen time, so I should dwell on it a little more. The semi-sentient Sophons, under the command of their extraterrestrial masters, interfered in Earth's experiments, distorting their results. Or rather, making the same experiment yield different results under identical conditions. Obtaining impossible and inexplicable but indisputable results led scientists to believe that all known physics was nothing more than fiction, or rather, a simulation artificially created by higher, powerful beings. Realizing that they had devoted their entire lives to studying essentially someone else's elaborate tricks, scientists fell into despair to such an extent that they began to commit mass suicides. Here Liu Cixin perhaps dramatizes slightly. Science is such that even a negative result in it is a result, and even the most unexpected outcome of an experiment is unlikely to drive the conducting scientist to despair as described in the three-body problem. However, the idea itself is sound. Indeed, modern physics critically depends on the results of sometimes very complex and difficult to reproduce experiments. So by falsifying the results of 2, 3, or even a dozen experiments, theoretically, one could indeed misdirect fundamental physics, leading its development into a dead end. Imagine what would remain of modern physics if someone powerful and malicious had falsified the Geiger-Marsden experiment, proving the existence of a massive and compact atomic nucleus, or the Stern-Gerlach experiments, leading to the understanding of particle spin. Without the results of these experiments, we probably still wouldn't have discovered quantum mechanics. And without it, there would be no microelectronics, no lasers, no nuclear energy, and if you think about it, a whole host of other things. Simply put, we would still be living with technology at the beginning of the 20th century. And if Sophons had arrived on Earth in Faraday's and Ørsted's time, who knows if we would have even mastered electricity at all. One of the most striking examples of subversive activity by the Trisolarans, depicted both in the book and the series, is the episode with the winking universe. In the Netflix series, it is portrayed in a very populist manner. supposedly by unfolding into three-dimensional objects and attaining sizes exceeding that of Earth. The Sophons displayed to humans a picture of pulsating starlight in the night sky. In the book and the Chinese series, a much more impactful approach was chosen. There, it was not stars that pulsed, but rather the so-called cosmic microwave background radiation. We covered this radiation in a separate video, and I'll just remind you now that this cosmic radio wave background washing over Earth is a kind of echo of the Big Bang. Its characteristics are directly determined by processes that occurred billions of years ago. And if it were found that there was someone who could adjust the parameters of this radiation at will, it would undoubtedly be the most frightening discovery in the history of physics. This is definitely not your ordinary twinkling stars from Netflix. In general, the creators of the American series managed to remove from it almost everything that I liked in the original three-body problem, specifically in the first part of the trilogy. On the other hand, what we got in the end is a sufficiently dynamic, unlike the somewhat drawn-out Chinese version, and watchable film product, quite suitable for those who watch series to relax their minds rather than get bogged down in some not always understandable intricacies. For those who really want to delve deep, I definitely recommend the Chinese version, despite all its numerous purely cinematic shortcomings, or of course, the original book. Well, that's all from me. All the best to everyone, and until we meet again.